Namaste, and welcome back to JEE Mathematics with Typical Monk. This is class 29. Relations and functions. A relation is any link between two sets. A scatter of ordered pairs. A function is that link made disciplined. Every input handed exactly one output, no more and no less. From this single rule flows the whole language of modern mathematics. Domain and range, 1-1 and onto, composition and inverse. Get the definitions crisp and the diagrams clear, and questions that look abstract become almost mechanical. Today, relations and their types, functions and their kinds, and the ideas of composition and inverse, one idea at a time. Here is what you will master today. First, relations and their types. Second, functions, domain, codomain, and range. Third, 1-1, onto, and bijective. Fourth, the composition of functions. And fifth, inverse functions, one idea at a time. Let us set the foundation. A relation. It links the elements of one set to another, simply a set of ordered pairs. A function, a special relation in which each input has exactly one output. Types, reflexive, symmetric, and transitive, and together, the equivalence relation. Master line, a function assigns one, and only one, output to each input. Now look at the picture, a function from set A to set B. A relation. It is any set of ordered pairs linking a domain to a codomain. A function. It is a special relation where each input maps to exactly one output. Domain, codomain, range. The inputs form the domain, the target set is the codomain, and the outputs actually reached form the range. The rule: every element of the domain has exactly one image, and no input is ever left out. Now, the types of relations. Reflexive: every element is related to itself. Symmetric: if A relates to B, then B relates to A. Transitive: if A relates to B and B relates to C, then A relates to C. Equivalence: a relation that is reflexive, symmetric, and transitive, all three at once. Now the kinds of functions. 1-1 or injective. Distinct inputs give distinct outputs. Onto or surjective. Every element of the codomain is hit. The range equals the codomain. Bijective. Both 1-1 and onto at the same time. Many 1, 2 or more inputs share the same output. And into, at least one codomain element is never an image. Now look at the picture, the two key kinds. 1-1, injective. Distinct inputs give distinct outputs, no two arrows meet at the same point. Onto, surjective. Every codomain element is an image. The range equals the codomain. Bijective. Both 1-1 and onto, and such a function is invertible. The inverse. Only a bijection has an inverse function. Now the composition of functions. Composition. Apply G after F. We write it G of X. Order matters. F then G is, in general, not the same as G then F. The domain rule. The range of phi must lie within the domain of G. Associative. F composed with, G composed with, HK equals F composed with G. Composed with HK posed with HK posed. Identity. Composing with the identity function leaves a function unchanged. Now, the inverse. Undoing the function. The inverse. It undoes the function. F inverse of f of x equals x. The condition. Only a bijection has an inverse. The graph. The inverse is the reflection of the function across the line y equals x. Now match each idea to its name. Each input, exactly one output goes to a function. Distinct outputs goes to 1-1 injective. Range equals codomain goes to onto surjective. And reflexive, symmetric, and transitive goes to an equivalence relation. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. A bijection has an inverse. Correct. Statement 2. Every relation is a function. Wrong. Only if each input has exactly one output. Statement 3. An equivalence relation is reflexive, symmetric, and transitive. Correct. So the answer: 2 are correct, statements 1 and 3. The trap is the relation in statement 2. Now, the 2 mistakes that quietly cost marks. The truth: a function assigns exactly 1 output to each input. The trap: thinking every relation is a function, it is not. The second truth: only a bijection is invertible. The second trap: swapping the order of composition, G of is not the same as of G. Now test yourself. Answer in your head before the reveal. That is how G speed is built. Here we go. Question 1. Each input has exactly 1 output. That is, a function. Question 2. Distinct inputs, distinct outputs, 1 injective. Question 3. Arrange equals codomain, onto surjective. Question 4. Both 1 and onto, bijective. And question 5. Which functions have an inverse? Only bijections. Let us gather it all in one breath. A relation is ordered pairs. A function gives 1 output per input. Reflexive, symmetric, and transitive together make an equivalence relation. The kinds 1, onto, and bijective. Composition G of F, and the order matters. Only a bijection has an inverse, and it reflects across the line y equals x. Next class: inverse trigonometric functions, principal values, and identities. 1 input, 1 output. Everything in this chapter grows from one clean idea. A function hands each input a single output, no more and no less. From there, we ask whether the outputs are all distinct, whether they fill the whole codomain, and whether the map can be run backwards. 1, onto, bijective, composition, and inverse. Each is just a careful sentence about arrows between 2 sets. Keep the definition sharp and the mapping diagrams clear, and these questions become quick certainties. Next class: the inverse trigonometric functions. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time. You will crack G. I will see you in the next class.